Weld inspection is the act of critically examining a weld to ensure it meets the design criteria and intent for the overall structure. The importance of weld inspection is obvious. We don't want our grandmother crossing a bridge with substandard welds that could cause a catastrophic failure, sending her and a bus full of schoolchildren into the river. This highlights why weld inspection is so crucial. Weld inspection has countless applications across many industries. Welds are used in a wide range of products and structures, each with varying levels of criticality. For example, it could be something as simple as a handrail on a loading dock, or as critical as a weld in a nuclear or aerospace application. The first line of defense is visual inspection, which is a type of non-destructive testing, NDT. This initial evaluation looks for visible flaws or defects. Other NDT techniques include ultrasonic testing, UT, radiographic testing, RT, and magnetic particle testing, MT, which are selected based on the design and critical nature of the structure. These methods help reveal defects that aren't visible to the naked eye. Destructive testing, such as tensile tests, bend tests, fatigue tests, and Sharpie impact tests, is generally used when qualifying welding procedures, not in routine inspections. These tests may be used in forensic situations, but are not typically part of regular weld inspections. However, inspectors should be aware of their existence. Surface defects are those visible to the eye or accessible from the surface of the material being inspected. These include defects like porosity, cracks, undercut, and overlap. Internal defects, such as lack of fusion, incomplete penetration, slag inclusions, and internal porosity, can't be seen with the naked eye. These defects require advanced NDT methods, like X-ray or ultrasonic testing, to detect. Defects can result from a variety of causes, including poor technique by the welder, material issues, improper machine settings, or machine malfunctions. These factors contribute to the formation of defects during welding. In almost any industry, we have codes and standards, whether it's manufacturing airplanes or welding. Some common industry standards we use in welding include API 1104, AWS D1.1, and ASME Section 9. So why do we have these codes? They ensure we maintain a level of compliance with established standards. These codes provide a framework to ensure quality, safety, and consistency across projects. After completing an inspection, we need documentation. If there's no paperwork, it's as if the inspection never happened. I had an older inspector tell me this years ago. Inspection records are especially crucial when dealing with critical components, like nuclear reactors or offshore structures in the Gulf of Mexico, where a failure could result in $1 billion disaster. Welding codes set the baseline for quality and safety. As mentioned earlier, examples of these include API 1104, AWS D1.1, and ISO standards. These codes ensure consistency across industries and projects. This means that whether I'm building a structure in Butte, Montana, or in Miami, Florida, I'm going to get the same level of quality across both locations. It guarantees that what I get in one place will be the same in another. Now let's talk about project-specific standards. A project-specific standard is when a company or project takes a welding code and boils it down to what the inspector needs to know for that particular job. This might be 1 or 2 pages, or maybe a 5-page document, but it keeps the inspector from having to dig through a lengthy code. This approach minimizes the risk of misinterpretation, which can happen because codes are often complex and challenging to read, especially for those who are new to the field. When we're creating a usable inspection document, what you could think of as a recipe card that the welder or welding inspector can use in the field without digging through the code book, we aim to build a concise document that summarizes the key code requirements. This could be a 1 or 2-page document, or it might be shorter, depending on your specific needs. It's essential to include weld quality criteria, defect limits, and acceptance rejection standards in these documents. The reason is simple. It gives us clarity and allows for faster decision-making on site. We don't want a welder working at height on scaffolding, flipping through a welding code to find an answer when a clear, concise document could provide everything they need. Inspection tools and equipment are critical. For visual inspection, tools like magnifiers, gauges, flashlights, and even bore scopes may be necessary, depending on the situation. If we're performing non-destructive testing, such as ultrasonic testing or X-ray, We need to use the appropriate equipment for those methods. Additionally, inspectors must be properly geared up, including wearing the right personal protective equipment, PPE, such as vision protection, gloves when needed, and appropriate industrial footwear, like safety shoes. Just like in any other industry, whether manufacturing or construction, safety is paramount. This includes hard hats, gloves, safety glasses, and all the required safety gear to perform tasks safely and in compliance with project or facility safety policies. The goal is to ensure you go home with the same number of fingers and toes you came to work with. Safety isn't just about compliance. It's about protecting yourself and others on the job site. What are the steps in conducting a weld inspection? Preparation is key. We begin by reviewing the codes and understanding the project requirements, making sure we have a good grasp of the inspection documentation and any project-specific inspection criteria. Next, we go through the inspection process, which will depend on the inspection method, whether it's visual or another non-destructive testing method. Finally, we document and report our findings, providing feedback to the appropriate people or organizations through the proper channels of communication. Some common challenges in weld inspection include accessibility. How are we going to reach and properly inspect this weld? This is a common challenge because often the welds are not located on the ground floor. We may need a man lift, rope access, or to enter a confined space just to conduct the inspection. Environmental factors also come into play, like heat, dust, and poor lighting conditions, all of which can make it difficult to perform a thorough inspection. Additionally, having the right training is crucial. Weld inspectors must have the correct skill level to conduct inspections effectively and safely. For beginning inspectors, it's important to start with the basics. This should be covered in your training, but it's always helpful to have a solid understanding of welding fundamentals and visual inspection techniques. Learning to read and interpret codes is an essential skill for inspectors. Odds are you'll find yourself in a meeting explaining to an engineer why a weld needs to be cut out. Also, in your training, be sure to use your inspection tools on sample welds and mock-ups of possible configurations to get hands-on experience. In conclusion, weld inspection is crucial and can be considered a bedrock component of our society. So many things are welded, from bridges to airplanes, and even to aerospace and nuclear applications. This process is often understated in our daily lives, with the general public not realizing how important it is. They simply expect that when they drive over a bridge, it won't fail. As inspectors, it's important to stay updated on techniques and standards, continually educating ourselves on the current trends in our profession. Quality welds ensure the safety and longevity of the components that make up our infrastructure. Thanks for watching. If you found this video helpful, be sure to like, subscribe, and hit the notification bell so you don't miss any of our future content. Keep welding, stay safe, and we'll see you next time.